At age 20, a small paper cut is often a non-event, closing up and vanishing in less than 48 hours. But at age 60, that exact same injury can linger for weeks. This delay isn't just the result of the body wearing down over time. It points to a specific breakdown in cellular communication, a failure in the internal messaging system that coordinates repair. Your body hasn't actually forgotten how to heal itself. It has simply lost the specific biological signal required to initiate the sequence. In 1973, Dr. Lauren Pickart began investigating this communication gap at the University of Minnesota.
I was at the University of Minnesota, and I was studying heart disease at this point. And I was looking at the blood of people that had a heart attack versus people the same age didn't, okay? Or especially young people. And I found something was different, that the young people had more of a certain protein. And it took about 8 years to work through this. And I realized that there was a little protein in what's called albumin, a protein in the body. But a very small part of that was something else. And that is where the GHK came from. This took about 10 years to get through this point. And then finally, I had left the University of Minnesota and gone to San Francisco and working on my PhD in biochemistry. And I was able to isolate the factor from the blood. And I would get blood of medical students, and then I'd get blood of 60-year-old medical professors. And I would compare it. And the young students had a much higher level of this protein. Or it was actually a peptide. I didn't know what it was. And with age, this was declining. And so then I isolated it. And I didn't expect all the effects it came up to have over years. But it surprises me.
Isolating this peptide shifted the scientific perspective on aging. It transformed a vague process of decay into a measurable molecular deficit. This chart establishes the baseline for a 20-year-old. At peak health, GHK-Cu concentrations sit at approximately 200 nanograms per milliliter. By age 60, those levels drop to roughly 80 nanograms, a 60% collapse in the body's primary repair signal. This decline leaves the body's repair networks waiting for an activation signal that rarely arrives, resulting in the stalled healing we associate with getting older. This molecular chain is the key to that activation. To see why, we have to look at how it operates on a microscopic scale. GHK-Cu acts as a signal peptide, serving as a biological commander that issues direct instructions to nearby cells. Here, the peptide docks onto cell surface receptors, stimulating fibroblasts to produce high volumes of collagen and elastin. It also acts as a carrier peptide, binding to a copper ion and transporting it directly into the targeted repair zone. Delivering copper to the site allows the body to reconstruct microvascular blood networks and accelerate the regeneration of damaged tissue. GHK-Cu is biologically distinct. It is the only molecule providing both the command to rebuild and the raw materials required to execute that command. Moving past the cell membrane and into the nucleus reveals an even more significant layer of activity, its impact on human DNA.
One of the neatest experiments, this was done in a number of different animals. Say you get a pig, you inject them in the thigh with GHK for healing. And if you make a wound in the ear, and the ear heals up systemic through the entire animal. This is done in a lot of animals, and it kind of amazed me. The first time people started telling me, this was when at ProSite, I didn't even believe them. They were getting such fantastic results. In an animal, you inject it here, and it heals things here throughout the entire body. So that was such a surprise for me. The most important to me, for many, many years, I had cancer grants from NIH. And I'd worked on cancer, and cancer was really big in my family. And it's what really pushed me into medical research. That was a book I put together. The new book probably should be out in about 2 months. And it's called GHK and DNA, Reducing the Diseases of Human Aging, okay? And what has happened after the Broad Institute came out with all this data on GHK, they gave me, from the Broad Institute, over 22,000 separate experiments, 22,000, and effects of GHK on different genes and everything. Now there's only about 13,000 active genes. So everything was done about twice. Why work on animals or something else? We can actually look at the human system and see what it's going to do. And out of that, probably the strongest thing that comes out is the anti-cancer effects when you look at all these genes. And what's so good about human data, you're not digging through some exotic animal. Really, it changed a lot of research areas. At this point,
This peptide operates as an epigenetic switch, rewriting cellular software to wake dormant stem cells that have stopped functioning due to age. GHKCU belongs to the body's native source code, a natural instruction set for repair rather than an external synthetic drug. Dr. Pickhart's recent research has shown this peptide's ability to facilitate the repair of severe nerve damage that was previously considered untreatable. Studies have also documented significant anti-cancer effects, with the molecule suppressing tumor growth at concentrations as low as 2 nanograms per milliliter. By understanding this internal signaling molecule, we are proving that conditions once viewed as permanent decline can be overridden and repaired. This leads to the central question for longevity science. If our internal levels crash as we age, how do we safely reboot this master signal? To join the conversation on the future of non-invasive biological repair, comment the letters GHK below. The future of longevity depends on learning to speak the body's inherent language of repair.